I always see these huge clouds of smoke coming up when an aircraft lands. Why don't you just make sure the tires start spinning to make sure that you don't get that cloud of smoke coming off? Aircraft tires are fantastic pieces of technology in itself. They are able to take the pressure that comes from coming in with a 65-ton aircraft, landing at 260 kilometers per hour up to 2.1 Gs, that's 130 tons at a speed of a Formula 1 car, and they do not burst. The technology that comes into making an aircraft tire is fascinating. It takes a special compound of rubber reinforced with steel, nylon and even aluminium threads to make sure that they keep their form. You will also notice that while if you're looking at a car tire, for example, you'll see that the car tire, the structure is kind of divided into different blocks. You won't see that on an aircraft tire. You will just see that they're kind of grooved. And the reason for that is that car tires, truck tires, for example, they need to be able to take side forces as you are maneuvering down a road. You need to be able to take curves. The aircraft just need to be able to land and stop on a straight run, but the grooves needs to be there in order to dissipate the water. So we're landing on a wet runway, for example, or even to a certain extent flooded runway. We need to be able to try to get rid of or not be subject to aquaplaning. Very important. The aircraft tires are inflated to an incredible pressure. The normal pressure inside of a 737 tire is about 200 psi, 6 times as much as the pressure that you have inside of your average car. They're not inflated using pressurized air like you would do when you go to the to refill your car tire. They are inflated using nitrogen. It's an inert gas. That means that it's not, it doesn't change much when it comes to pressure if the temperature changes or if the pressure suddenly changes. It basically doesn't react much. When we are taxiing out an aircraft, it might be up to 35 degrees Celsius outside. Now, as we taxi along, we will probably be stopping at given times, we'll be slowing down, and every time that we use our brakes, the energy from our brakes is transferred into the brake discs. They become hot and they're very close to the gear. So the tires can be heated up. Then as we take off, retract the gears, we come up to our cruising altitude. We have a temperature outside of about minus 60 degrees Celsius. Stay there for a few hours. Temperature inside of the tires will down to 60 degrees. Come down, land. We start braking hard because it's a short runway. You will get almost glowing brake discs, which means that the tire are now heated up suddenly. This is why we have nitrogen inside of them, to make sure that these sudden changes in both pressure doesn't affect the overall performance of the tires. Why don't we fit motors, some kind of motors, either gas driven or driven on electrics to the landing gear? There are two different reasons why we would do that. The first one is actually maneuvering the aircraft when we're on the ground. So theoretically, there's no need to use jet engines to, get the aircraft taxiing along on the taxi lines. We could have a motor driving the aircraft on the ground and then get us to the holding point, start the jet engines up, and then take off using the jet engines. Now, this is actually a very good point, and this is something that I feel quite passionate about myself. Yes, it is very, very wasteful to use jet engines to be taxiing around on the ground. As an example, when we calculate a normal flight, on average, we use about 200 kilos of fuel for taxi. That's 2 months of you using a normal car, just for one aircraft, one 737, to do one flight. That could be done using other means. But is it really smart to use the aircraft's own tires for that, its own motors? Think about it. At the moment, it already exists electrical tugs. We have them. Here in Girona, we have electrically driven tugs. Why don't we invent or use a tug that can be remote controlled from outside or from inside of the cockpit? Use that tug to push us back from the gate, and then the pilots will be able to, maneuver it, connect it to the nose gear, up to the holding point, press a button, which would release the tug. The tug would then be able to, using autonomy, which we already have the technology for, drive back through some kind of side road, back to the gate, and then be used for the next aircraft. This technology already exists, and it will do all of these things that we just talked about. All of the technology would be in the tug, which means that all of the maintenance to the tug, the recharging of the tug, all of that will be done on the ground, where there's not so much stringent rules about it and there's no risk to the aircraft. So that's the first thing that people are saying. The second thing that people are saying, and this, by the way, is the most common thing, is that why don't you put motors on the wheels so they start spinning before we touch down on the runway? That way you will have much less wear and tear on the on the tires. But then you have to start thinking about what could go wrong with that. So the first thing is the actual fitting of new technology to the existing gear. So you would have to come up with a foolproof electrical motor that will be running the tires, and they need to be strong enough to get the tires up to the speeds that we're talking about. So 260 to 300 kilometers per hour, they need to spun them up to that. Now, if it's an electrical engine that does this, it has to be connected to batteries, and those batteries, if they are connected to the engine, also the motor itself, is going to be very close to our fuel tanks, which are in the wings and in the center part of the aircraft. Now, putting batteries, especially large batteries, onto aircraft comes with its own risks. We saw that in the 787 development. When the 787 was just released, they had some huge problems with batteries. Batteries is an issue. Adding of this is going to also add to the overall weight of the aircraft. And as I've been explaining before on the channel, when you add weight to the aircraft, it's going to burn more fuel. And if that is, a lot of weight for a lot of time, that might actually negate the economical benefit of getting the tires to move in the first place. Number two is, as always, getting it certified. So as I was alluding to before, since it comes with potential risks, it would have to be certified by the FAA, by the CAA, by EASA. All of these regulatory bodies would have to come in and make sure that this is safe under any circumstance. Number three, the single biggest reasons why this is very, very hard to do and probably undoable is the safety aspect of it. It's how we are controlling the aircraft during landing. So when you add new technology to an aircraft, you always need to assume that that technology might fail. Okay? So if we will be coming in and landing with an aircraft and we had motors that are now spinning up the tires to 260 kilometers per hour, first of all, they need to match exactly the speed of the aircraft. That's a problem because we are landing in windy conditions with headwinds, tailwinds, crosswinds. The ground speed that we're landing with is going to change very, very quickly. And the tires need to be able to accommodate these speed changes. If they don't, we are going to have potentially more speed on one tire than the other, and you'll have controllability issues. That's number one. Number two is, what about if one of the motors fails? You now have one motor spinning at 300 kilometers per hour, the other tire is not. When we touch down, there's going to be a huge difference between the two, so you might get the aircraft suddenly wearing to one side. Number three, we are very, very often coming in and landing with what we call a crab angle. Now, during the last part of the flare, we tend to put a bit of rudder in to align ourselves with the runway. But if it's a slippery runway or a wet runway, or if the crosswind is too strong, we are actually going to land with a bit of that crab in. So that means that we're landing with an angle towards the runway. That puts a lot of pressure on the landing gear, right? But there is torque functionality in the landing gear which allows us to do this, so that we land, get a bit of a jolt, and then we line ourselves with the center line and we continue rolling down the runway. If you would have the aircraft having spinning wheels and we're landing with an angle, you would have a different problem. Now you have something that's actually driving the aircraft off the runway, which is actively pushing the aircraft off the runway. All of these factors combined makes it very, very unlikely that you would ever be able to see an aircraft coming in with spinning tires. And on top of that, you have the economical factors here. Changing a main tire on a 737 costs about $1,500. If you'd have to change an engine on an aircraft, it's about $12 million to do. So these are the normal count of money that airlines are used to pay when it comes to maintenance. $1,500 is very little when it comes to that. It is very little even if you compare to the fuel cost of the aircraft. So all of these things combined makes it very unlikely as in I say, almost surely impossible that you will ever see this technology ever being fitted to an aircraft.